Good morning. This is a train the trainer session. So I'm going to go through the slides with a presenter note and I'm going to try to explain them. Few things to explain where is this slide deck come from and what is the overall idea behind the slide deck. One of the things we try to do is we try to be very, very intent on what we say, why we say it, and try to be as precise as we can. So this specific slide deck, the intent behind it, stem from talking to tens of people at conferences from the previous slide deck to be able to address the most pressing need. And the most pressing need is where do I get started and what should I pay attention to? One of the problems of SAIF, and I'm one of the original writer of it, is there are very, very good principles and there are very extensive risk and control for AI. But if you ask anyone who is working on a product or a company which just try to integrate, this is too much. This is overwhelming, and it's very, very difficult for them to know where to get started. So what we try to address here is for the audience who is interested in the topic and want to invest a little bit of time on it, but it's not their job. They are more interested into deploying the capability. So we try to say, okay, here's what we want to do. Here's how you should think about it. And here are the 5 things you should really do. And that is to help you grow with the thing. It is not for you to become full-time security expert into AI, which is not the right content for most of the developers we have. We start usually with an opening for what is the generator revolution. And we tend to explain that, for example, Google have built quite a few AI systems in the past. I usually personally cite the Gmail spam filter because I worked on it. And of course, Gemini, which is our frontier large language model. Those systems are extremely complex and provide very exciting capability that everyone is excited to use. And then we explain, of course, that like every other system, those have vulnerability and risk. And so as we build such a system, taking into account security is very important. And the image you see here for contextualization is one of the bug which got reported to us for Gemini by someone called Embrace the Raid, and it shows some problem with exfiltration, which is a mix of web security and AI bug. And as you go through the slide, I would encourage you to go and read the references that we have put in every slide, which provide more context so you're able to understand what's behind the story. But here, essentially, the point that we're making is, as you can see here, every AI have vulnerability and face numerous threat as well. One of the things you will see in every one of the slides I make is one slide, one point. What I ask you to do is to try the slide. The slides were meant to be quite fast-paced, and they meant to have one idea per slide. And don't worry, the point you would like to make in your head is going to be probably made in the next slide. And we keep this very fast-paced to keep the audience engaged. And we try to have the narrative, as I said, as focused as possible. So I'm trying to give you really like a sub commentary on how the slides are made as well, so you understand what we do, and how we do it. All right, next slide. So the next slide, which is animated, is essentially a way for us to show the overwhelming amount of things that have popped up, are discussed in the press, and you have to face. And the goal of the slide essentially is to say, well, there's so many things, and many of those things are classical risk. And this is one of the theme which is very important in this presentation, which is, yes, AI systems are exciting, and yes, they have some new capability. However, it's not all new, and it's not because it's AI that good fundamental goes through the windows. And you have to be still very principled and still be able to do things like this. So we have a bunch of different type of attacks into the slides. You don't have to go through them. That's not the point. I will now go through them because we have a little bit more time. and explain what they mean, just for you to know. Hopefully, you are familiar with every single one of those terms. If you are not, I would encourage you to spend a moment to read about them, because we do get sometimes question about specific one of those. I did have those in the past when I field tested those slides. And the slide you see, as I mentioned, I field tested it through the summer through various communities. So I can give you kind of pointers of where I got stopped, the question I got asked, so you also understand that. So from bottom left to bottom right, I guess we're going to do clockwise. Biases. So this is a risk concerning the model or the AI system as a whole. You can do also retrieval, RAG, agents, whatever you want. The system not being able to perform equally well everywhere and having some sort of a slant towards one thing or another, which might be problematic. The second one is prompt subversion. It's not a good term, but there is no good term. It is, for example, what people call prompt injections, where the attacker is able to add something to the prompt or do a multi-turn conversation or add an image such that the model or the system start to misbehave and produce unsecure or unsafe output. Model backdoor is when at training time or fine-tuning, and if you're not familiar, you should familiarize yourself with the difference between training and fine-tuning. Essentially, training being when the model is trained on a very large amount of data for a very long time, and that is the main training effort. Fine-tuning is what is offered to most developers to adapt the model to be producing an output or using a tone and a form which is more suitable for the audience and the application, kind of tweaking it, if you would. And in both cases, you can have a backdoor. And there are multiple ways to do it. It might be in the code, it might be in the data, and we'll go through that through the slide deck. Hallucination is when the model is producing an output which contain factually incorrect data. If you ask like how often does that happen, it's hard to quantify, but when people traditionally cite hallucination in papers or example, we see something around 20%, 20, 15%, something like that. PII leak is private information leaks that happen a lot when people train the model or do a retrieval system. So fine-tune the model or do a retrieval system, and the model contains data which should not have been trained on, like consumer names, consumer data, like addresses, personal bank accounts, things like that. Model weaponization is when the model is used for offensive capability. This is one is a little bit more complicated because there's a lot of regulation, but let's just say dual use or using it by bad actors. And then infrastructure vulnerability, that's very important to realize, is when you talk about an AI, we're talking about an AI system, and you usually have a lot of things around it, from the GPU processing it to the software stack which is serving it to the front end which allows you to communicate with it. And as a result, you might have vulnerability through the stack. The point we're trying to make here is there is a lot of vulnerabilities, and quite a bit of them are very classical risks that are faced by any system. And some of them are AI-specific threats. They are all important to address. And as a developer, you should not make the mistake to only focus on the new thing, because by doing the classical thing, you get 80% where you need to be to secure infrastructure. Then the slide 5 is talking about SAIF. We created this framework because we needed something to secure our own product. We did outsource this framework to help people reproduce and reuse what we learn so that they can secure their own system. SAIF is not a standard, it is actually more like a framework to think through those things. And then we have a bunch of principles on slide 6, and the slide 6 is basically going through the 6 principles. As you can see in the speaker note, we don't expect you, or we don't expect anyone doing this presentation to go through them. If you do this, you are incurring about a 5-minute additional presentation time, and that's maybe doable, maybe not doable. The slide deck is meant to be 25 minutes. So if you were to add a discussion on the principle, you should account for the 5 minutes to go through all of them. They are discussed online, so I'm not going to go through them because that's not the point. The point of the slide say we have those first principles that we're using to derive everything, including the first one and the one I usually mention, but you can pick any of those that you want. You can say including. And then I like the first one, which is expanding from a strong security foundation. And I try to belate the point, maybe to an extreme, that we are building on existing thing. And by doing things that you already know, or by using good security practice, you'll be fine. The reason why I do that is because we see a lot of problems with systems where people forget the basic, and as a result have problems that should never happen, like denial of services, insecure code, web security vulnerability problem, improper securitization of how they store tokens. And they happen because people think because they go fast, they need to scheme on those foundational principles. So that's why I, on purpose, in the slide deck, belay the point that we are building and extending. And now, just to be clear, I'm going very, very slowly on those slides to explain and subtitle them. The way I would present that slide for real would be going back and say, there is a lot of vulnerability into an AI system. Some of them are classical risk, some of them are a specific threat. To help protect against those things and help us think through and help Googlers to build a GenAI capability into Google product, we have created something called the SAIF, the Secure AI Framework. We thought it was useful, so we decided to make it available externally for people to benefit from our experience and share what we learned so that they can apply it and make it their own for their own system. SAIF is built on top of a set of core principles that you can find online, which helps you to derive a secure by default system. For example, the principle number one is to extend well-known good principles and adapt them to AI, because a lot of the security problem we have with AI can be mitigated with standard good practices. And that is about the space at which I would have done the 3 slides. So I just want to show that because we've been going very, very slowly the first few slides, but I thought it was important to give you all the context so that when you have those slides, you understand where they come from and how they're designed. All right. The next slide is animated, and it's a tour, and we go clockwise. We start with we have the data part, the data component. So we call this component, and we show it a bird eye view, and we explain every single one of them in turn. So we start with data on the top bottom left, and we say we have data, the data component, which is in charge of getting the data in the system and storing and maintaining the data. Depending on how much time you have, if you want to do a 20-minute slide deck instead of 25 minutes, then in that specific case, this is where you can go a little bit faster. So with data component, that's where we start the data infrastructure, which is in charge of training, serving, and hosting the model. The model itself, number 3, which is the heart of the system. And finally, the application part of the stack, the component, which is in charge of communicating with the user, which you can think of the front end, but also the plugin, which allows the model to interact with tools and other services to make the model being able to do things. And then around everything, and usually I do an around gesture, is governance and insurances, which ensures that the system remains compliant. And that you can do from 15 seconds to 2 minutes. Then we show the concretized version of those 4 components and explain how we break them down. You can point the audience to the site and say, well, you have an interactive map of that you can explore. We don't explain those components, it's just overwhelming. We just say in practice, there is far more sub component, and You can explore them, but essentially the point here is those interactions exist and we need to secure all those things. And so we don't spend much time here. We just explain that it exists and we show the concretization of the map. Then we go to how we overlay things on top of the AI system. We start to say on top of the system, you have a layer of risk, and we separate classical risk, which are the risks that are faced by the system but are well-known quantity and affect any other system. And then we have AI-specific risk, which affect AI specifically. And then you say we address those by having controls, and the control helps you mitigate those risks. And again, we use the word mitigate to be able to carry that there is no perfect defenses. And we insist here on having built defense in depth, and there's multiple controls. We have defense in depth, meaning the principle that you don't have to explain that, it's for you to know that because none of the control might be enough by themselves, layering control increase security by having more than one. And we're going to start to talk about data because we're going to go around the map. And again, we have this analogy for you, if you remember, where we're going to go to around the system tour. So we have data, we go around the thing, and for data, we chose to say the first risk we want to talk about. So we're missing one slide between 9 and 10, which is about, okay, how do I get started? There is too many of them, right? How do I get started? And the answer is top 5, okay. And then the first one is data poisoning. And here I'm going to attract your attention to the bottom right, where you'll see we have what we call our navigators. And you can see we are the first quadrant, second layer. So this is data risk. And so this is data, just to show you the navigator, right? Data, this one, and then risk, second top. You can point it here to help people to understand where we are. We keep the color consistent as you go through the slide. If you don't know where we are at, essentially red means attack and blue means defense. That's standard practice in the industry. And so here we say the first risk is data poisoning, and then we briefly explain what it is, which is why you don't need to explain backdooring here, because we are covering it later. So that's what I meant by trusting the slide earlier in the discussion. And then we say, here's a concrete example. And here we explain, this is a production graph I took from Gmail. And I explain what it is. And that's one of the slides that people really like. So we spent 35 seconds on it or 45 seconds on it. And the idea here, we say, one of the ways we measure AI performance system is by looking at false positive and false negative. For Gmail, like many of the customer-facing products, leverage user report to help with that task. And one way we do that is we count a false negative when the user moves an email from the inbox to the spam box, and a false positive when we move the email from the spam box to the inbox. So here we define very concretely what it is. The graph you see is a real production graph that shows how many emails are moved in both directions. Green is when you move from the inbox to the spam box, and red when you move from the spam box to the inbox. Here, do note that the audience might be colorblind, so I would suggest to say the green top line, and then as always, with external input, spammer try to abuse those things and try to poison our classifier. And we explain they do it by creating fake accounts and doing a send email to them and reporting them as false positives in the hope that the next message will not be in spam folder. To avoid that, we have to analyze and filter reports extensively before taking into actions. Here what's missing in the slide note, as you can see on the slide, we clearly see spikes of false reporting that would poison the model if taken, and that's the point. The point is to show very egregious spam false reporting. In practice, when we see attacks, they might not be as egregious or as visible as those. They are just like a very forceful example that we did observe in the wild a few years back. And then we say how to mitigate that. So more generally, the way we would address that is to never trust external input. even if the reporting mechanism is under your control, because it can be gamed. And instead, you carefully have to filter the data before using the training, and that's our number one important recommendation. Never trust user input, and you can say that is the same as any other systems, including web security, where we tell you to filter in and filter out. So trying to help the audience to realize that they already know what to do in other things. And so here we explain that another part of this filtering, which is also very important, is making sure that when you use private data, you filter and sanitize it before including the data into the training data, and you have to remove properly all the PII, and that is, of course, data governance and insurances. And if you remember here, I will show you it briefly, but you don't do that to the audiences. That is why we say governance and insurances is around the system, because it affects every component. And so here is like you have to make sure you manage and audit your workload to make sure you don't include data that might be problematic for your system. And this is in simple, nice animation, which I like. And then we explain that one of the ways Google helps you to do that, and I encourage you to familiarize yourself with that system. And it's really, really a neat system which has been built recently, is the way we help on ensuring that the right data goes into your model is to implement data lineage to know exactly which data was put into the system, transformed, and so you can go back. And that is done automatically by Google Cloud. As DevRel, we of course show the cool things that Google Cloud can do, and that's one of those cool things which can be done. And so the data lineage API now properly work with BigQuery, Data Cloud Composer, and Cloud Data Fusion. So most of our product for data transformation, and you can show a demo of it. So here we put a screenshot and animation. If you have a little bit more time and you like this API, you can pause here, do a short demo, answer the audience question about how to use it, use your imagination. But I think that's one of the amazingly useful things that is underrated, and I don't think people understand how important it is until we have done the spiel about don't get your data poisoned. And so I think that's one of those places where you can stop and make the presentation your own and do the demos the way you would like. Then we talk about the fact that there is a ton of system in Google Cloud which helps you manage your data, and they are pretty useful and you can use them. And here I would suggest that you can pick the one you like the best and you can explain, or you don't explain any of them. So this is more like choose your own adventure slide. Then we go around the clock, right? So now we're in infrastructure. And that's why I said we don't spend time much at the beginning of the slide, because we're going to repeat things. And I found that more useful to re-explain, oh, this is infrastructure part of the component with second quadrant, because it's better to space the thing. As we unfold the thing, it starts to click into the head of people, and by the end, they're comfortable with it. We go back, it's a red slide, so we know it's attack. We know, thanks to our navigator, even for ourselves, that we are second quadrant top. And we say here what we're concerned about is model source tampering. And so we explain this when the code or the structure of the model is itself alterated, or when the data is alterated on disk. And that can be the data who goes into the training, but also the data who goes into the retrieval. If people use something like called the RAG, which is a retrieval augmented generation system, which actually do data fetching directly. And then I think that's probably one of the most important slides in the talk, is we show that one of the things that people sometimes overlook is the model file you load from disk is a bunch of weights, but it's also it's Python code. And those code can be modified and tampered with. And while we don't want to single out anyone, and we really don't, and Hugging Face is our friend, and we love Hugging Face, they had this study done, and they found quite a bit of models who had been spiked with malicious capability. So reverse shell means literally having access, establishing a connection back to give the attacker access to your Colab or to your machines through the system. Some of it is extracting data and so forth. And so what you can say is, because the model is code, if the code is modified and you don't authenticate it, then you end up having a malware on your computer. And again, that's a classical risk, but it's very important to understand that model is code. And I think most people don't understand that. And sometimes it's very, very hard to know what is poisoning because a model architecture in itself are a bunch of layers. But so what people don't know when they do those abstract presentation is a keras layer or any a torch layer, it doesn't really matter, is Python code. And you can absolutely decide to inject another layer and to reroute how the model behaves based on specific triggers, even after the fact, so you can backdoor the architecture. And even for people like me who are very well versed into what it looks like, if you show me a very precise backdoor on a transformer architecture, I might not be able to see it. It depends how well it is done. And so the best approach to avoid those things is to enforce access control on all model code and data, right? And this is one of the things you can drive home to people is access control is very important. And of course, if you use Google Cloud, it is very easy, or if you use a Google product, it's very easy, but even if you want to use AWS or whatever you want, making sure there is no public bucket. And there's so many stories about public bucket, data on the public bucket. So I think the point here to say, this is one of the easiest things to do, but it's overlooked. And now we're back to my first point of if you do correct listening, which we know to do really well generally, you are 80% there. This is one of them, which is have proper access control. Don't let your model code being accessed by anyone. Don't leak your API token key on GitHub. Don't let data on the bucket to be publicly accessible. And those things are classical recommendation. And they are very simple to implement, and they should do it. And then we can talk about a more advanced thing. Provider can sign the model to ensure that model weights and code haven't been alterated between the moment the provider releases them, let's say Meta, Google, Mistral, and the moment you load them. And so you can verify model origin, and it starts to be integrated everywhere into the open source system. Then for access control, we show also that you have, and I probably should invert them, so you have access control, and we have plenty of way with posture management. So the security command center to look at who have access to what, which model, what are your policies, and making sure that your access control is as tight as possible. And we have this other thing which is useful, let me put it actually before, is you can use VPC, virtual private compute, to make sure that you isolate your workload in production, which helps you to have defense in depth, right? As I mentioned before, when we said a little bit earlier, we want to layer defense in depth. Even if you get compromised and things got in, we limit access to things. And then you have Vertex login, which helps you to know who access your AI system and making sure that if you have an incident, you have all the login infrastructure in place so that you're able to react properly, which is part of this recommendation. Then we go to model. And in model, we talk about prompt injection, which is the thing that people care the most about and the thing which is most in the press. And we explain it as crafting malicious payload which tricks AI into generating unintended or harmful output. And then we show this very nice example, which was on Twitter, on how you add invisible white images into a resume, and that derail the system to say hire the person regardless of what the instructions are. We also point out here that those type of attack, people discover them now because they're interested in AI, but the reality is those have been around for now a decade. And so that just to explain that it's not a new thing, however, it's an AI-specific thing, and you have to be careful about those. And that's what our recommendation is to make sure you also do filter the input to your model and your prompt and have safety filters, including transcoding the file. And then the flip side of that, I'm going faster now because we have understand how the presentation works, is unsafe content generation, which is the model is outputting unsafe content from harmful to violating the policy you want. So for example, it might give financial advice and then your company is on the hook for it, like Delta generated, promised a user a refund of a ticket. And they say, no, it was an AI mistake. But then the court said, no, your support said it, so you have to do it. So that's an example of giving an unwanted answer. You should have control. My favorite example in this case is at some point, some church decided to put a priest AI, and then it went really, really bad because it offered to baptize people with Gatorade or other things. And so you end up into this place where the AI makes a recommendation which are offensive to the people and your audience into the settings you are making your system. And as a result, there was a massive backlash. So it's very important to avoid the model generating unsafe or privacy violating content. And so the recommendation here, number 4, is filtering out the system, literally like you would sanitize a web application for web security vulnerability, concatenation, and safety filters, which are making sure the model doesn't say anything which is violating your policies. And here we show that we have the recently launched Model Armor into the security part of Google Cloud. Go play with it if you haven't done yet, and you can configure what's authorized or not authorized to be output. And then we have specific control for images. For example, people might not want to generate human. And then for people who like to do it open source and do it themselves, we have Shield Gemma, which is a open source model which you can use for safety output and input, because it was one of the most requested things we got, which was, can we have an open source version of that we can run ourselves? And then says yes, here it is. If people ask you, is there other version of it? Yes. Purple Llama from Meta is also doing about the same thing. And so people have options. And then for application, last control, if you have to keep track, we have recommendation number 4, it's written on the same. We talk about insecure plugin. And the reason being, most of the bug reports to us so far has been around integration. And so if you don't unsanitize plugin output, you have data exfiltration. Again, a classical risk. Very important to explain that it's a classical risk. Access control to plugin has always been a problem. And so you have to make sure you enforce least privilege. Don't let your AI run code on your production without sandboxing. Don't let the AI access the internet directly without filtering. And you can do that with a bunch of technology like ShieldVM having a notebook scanner. And so you can go through whichever you like and how fast you would like or not would like, depending on how you want to do it. And then we'll recap and we'll go back, say, here are the 5 recommendations. And you can go back and you re-explain them, which is sanitize your training data and track data of origin carefully, enforce access control, filter the thing, filter, blah, blah, blah. And then we say that there is also this COSI AI, which is interested into making AI safe for everyone, which is for every company interested in that. And if they're interested into joining, and then we thank people. And that is how it works. So it's 44 slides, it should be 20, 25 minutes, depending on how you are.